Okay, so this is a lesson on graphing cube root functions and finding key features of that graph. We're going to start this with SLT 7. So everyone go ahead, grab your packets, open up to SLT 7, a cubic and its inverse. And I want everyone to also please note that homework tonight is SLT 7 Flexbook, the Explore More section, but I want you to please make a note to change the directions to find the inverse function. I don't know what the directions are, but I would like you to find the inverse function for numbers 4 to 15. Please also note we have an exit ticket tomorrow. It will be reassessable, but everyone should put forth their best effort the first time. Okay. So what we're going to do is we are going to have a lesson on graphing cubes and cube roots. And this is going to look really similar to graphing squares and square roots. So here we go. SLT 7 asks us to graph the function f of x equals x cubed. And then on the same grid, graph the relation that represents the inverse of f. So here we go. If I have 0 cubed, that will be 0. If I have 1 cubed, that will be 1. If I have 2 cubed, that will be 8. If I have 3 cubed, that will be 27. That's off my paper. So now, if I have negative 1 cubed, negative 1 times negative 1 times negative, ooh, that did not come out good. That's a negative number. So negative 1, negative 1. 3 negatives multiply to a negative. So I've got negative 2, negative 8. Now I'm going to do the inverse relation in red. So if I've got negative 2, negative 8, I've got negative 8, negative 2. Negative 1, negative 1, 0, 0, 1, 1, and then 8, 2. And here is my inverse function. I know that you're not familiar, but the curve on this one is going to kind of come down. Oh, poop, I missed. There we go. And then this one kind of comes up. So they kind of, see how they kind of do this little jamming in the middle? All right, let me get my eraser and just neaten this up a little bit. All right, so the question I want you to think to yourself is which point on the graph do you think is significant? And what I want everyone to do is put your finger on that point. Look at your neighbors. Do they have their finger on the same point? If you have your neighbors have your finger on the origin, that is correct. That is our symmetric point. This graph has symmetry around that point. If I picked up this blue piece, if I had skills, or if I had like one of those wax bendy things or like a pipe cleaner, I could, or you could open up a paper clip and bent it to this shape, kept it on the origin, and then rotated that 180 degrees, it would match up perfectly with the curve in the third quadrant. So that is our significant point, 0, 0. So what I would like you to do is answer the questions with your group and pause the video. When you're ready, unpause the video. Okay. So, how are the graphs related? They are reflected over the line y equals x. That is how they are related because we found the inverse, so obviously they are a reflection. Determine the domain and range of f. Both the domain and range of f of x equals x cubed are all real numbers. The inverse, both the domain and range of f inverse equals cube root are all real numbers. Are they both functions? Yes, they both pass the vertical line test. This means that each input x has only one output y. Remember, vertical line test alone is not a sufficient explanation. Now, I want to point out the cube root, the cube root of x, if I want to use that, like the cube root of 8, what number multiplied 3 times gives you 8? What number multiplied 3 times would give you 27? What number multiplied 3 times would give you 64? Cube rooting is the inverse of cubing, just like square rooting is the inverse of squaring. So everyone go ahead and turn to page 2 of SLT 7 and let's take a look at that one together. Here we're asked to graph the function x minus 1 cubed on the coordinate grid. Well, immediately I notice that this graph is just like my parent graph on the previous page, but it moves right 1. So that interesting point at the origin is now right 1. And now if I plug points in, 2 minus 1 is 1, 1 cubed is 1, 3 minus 1 is 2, cubed, and then if I went to 4 minus 1 would be 3, and cubed is 27, so that's too big. Whoop. All right, now go the other way. And 0 minus 1 is negative 1, cubed is negative 1. Negative 1 minus 1 is negative 2, cubed is negative 8. And then again, when we get to 3, we'd have, or 2, we'd have the problem of 3 cubed. That's too big. And so here's our function. Question 7 asks us to use what we know about inverse functions to determine the equation of the function that represents the inverse of f. So let's map this out. To get f, we took x, and then we subtracted 1 to get x minus 1. Then we cubed, and we got x minus 1 cubed. So to find the inverse, we're going to do everything backwards. We're going to start with x, but the first thing that happened was cubing. The opposite of cubing is cube rooting. So the first thing I'm going to do is take the cube root of x. Now, working backwards, I did this. I subtracted 1. So the opposite of subtracting 1 is adding 1. So my inverse function is going to be the cube root of x plus 1. So let's write that down. Okay, so it's asking us on the same grid to graph f inverse of x. Now there are 2 ways we could do this. We could just take the ordered pairs that we graphed with the cube function and just, graph those points inverse and then make a connection. And that would be really, really easy. But what I want to do, because this is our first cube root with a transformation, is actually graph our function, the cube root of x plus 1, using a table. And I'm going to show you how we're going to do that. So we have f inverse equals the cube root of x plus 1. Now the trick is to pick x values in our table that will, that will make the argument a perfect cube. Now since our argument is just x, we can just pick perfect cubes. So I'm going to pick negative 8. This board is really on my nerves. There we go. Negative 1, 0, 1, and 8. So the cube root of negative 8 is negative 2 plus 1. Cube root of negative 1 is negative 1 plus 1. The cube root of 0 is 0 plus 1. The cube root of 1 is 1 plus 1. The cube root of 8 is 2 plus 1. So here we go. We've got negative 8, negative 1, negative 1, 0, 0, 1, 1, 2, and 8, 3. And here is what made it, our cube root function. Nice, and you can see it is a nice reflection over the line y equals x. It kind of looks like a, I don't know, it kind of looks like a snail. Okay, so we did that, check. Determine the domain and the range of the inverse function. Well, here we have a domain and range of all real numbers. All right. Now it asks us on what intervals is the function increasing or decreasing? When I look at this function, it's actually increasing the whole time because it starts down here and it just slowly travels up. So I'm going to say the inverse function is increasing over all real numbers. What are the coordinates of the point of symmetry? So that's kind of like our magic point, our shift point, our center point. And here it is, where is it? Right here at 0, 1. So we're going to say the coordinates of the point of symmetry are comma 1 for the inverse function. Please make sure you're answering in a full sentence. Please make sure that it's clear to the person reading your work that you're referring to the inverse function and not the original function. Please make sure you're using good math vocabulary. Okay, so once you have that done, what I want you to do is switch to the next page, page 3, and I want you to go ahead and get the graph done, get everything down to number 15 on the same grade, graph f inverse of x. Go ahead and pause the video. I'm just going to work through that, so when you unpause the video, you'll see me working, but I'm going to kind of go fast and I'm not going to explain as I go. So go ahead and pause it and work down all the way down to number 15. Oops, oh well. So minus 3 to plus 3, and then after subtracting 3, the next operation we did this one, then we cubed it, so it'll be cube root, and then the first thing was plus this. Okay, so everyone should get the function, the cube root of x plus 3 minus 2. Now, to graph this function, we are going to be very careful in our selection of x values. I'm going to rewrite it here. So here's our inverse. The numbers we want to pick, we know where the shift point is. We know where the good point is. So we know we've got, let's see, so this plus 3 and then minus, plus 3 minus 2. Okay. So we know we're going to have a point at -3, -2. So I'll just put that one in there. -3, -2. We know we've got a point here. And we know we probably have a point on each side because that's the one for the 1. So I'm going to put in the middle, I'll put -3, -2. And I know that I'll have one at -4 and at -2 because here's -3, and I know that just because I'm very familiar with the cube root graph now, I know that if I go over 1 on each direction, I'll have a nice point. So if I put -4 in here, I get -1. The cube root of -1 is -1 minus 2. Oop, that should be a -3. And then the cube, this becomes the cube root of 1, which is 1, minus 2 is -1. Okay. So that's 1. So the next perfect cube, because remember my perfect cubes from before are 0 and then the 1s and the 8s. So the shift point is the 0. This is like with a cube root of 0. Here we took the cube root of 1. So the question I'm asking myself right here is, what will make this argument equal to 8 and negative 8? So real quick, I'm going to say, all right, well, if x plus 3, oh my God, that's ugly. If x plus 3 equals 8, the x value I am looking for is 5. Okay, and then if I want another argument, if I want this argument here to be negative 8, the x value I'm looking for is going to be negative 11. So what I'm going to do is, I know that I want the argument to be nice numbers. I want them to be 8, 1, and 0. Well, the 1 and the 0 are easy because the 0 is just the shift point and the 1 is the one on each side. So to get the 8, I'm going to go negative 11 and 5. And again, all I did is I took this argument and very quickly set it equal to 8 and negative 8. So now watch what happens. If I put negative 11 in for x, negative 11 plus 3 is negative 8. Yay! Cube root of negative 8 is negative 2. And then minus 2 is negative 4. 5 plus 3 is 8. Cube root of 8 is 2. Minus 2 is 0. And so there are my nice points. I had no decimals, which is nice. I didn't need a calculator. I used my brain because we are all smart people. So I have, here's the other one. Boop, boop. Hey, come on, Slate. And then 5, 0. And let's see if we can get a nice smooth curve. There we go. All right, I really should have arrows. That would be better. Some arrows on this. All right, so go ahead and answer 16, 17, and 18. Pause the video because I'm going to type the answers in. So, what I would like everyone to do now is to work on pages, on SLT 7A, and I'm going to really quick just do number 5 with you because that one is a little tricky, and then you are on your own for the rest. So let's skip to number 5. All right, so first thing I want to do with number 5 is notice that I've got a shift point at negative 4, negative 1. That is my point of symmetry. Now, because we're honor students and we've now done 3 cube roots, common sense tells me I know that my domain and range is all real numbers. No matter how you wiggle the graph around, that's what it's going to be. So let's see, negative 4, negative 1. And I'm going to use that trick again. I'm going to go 1 on each side because I know it's a cube root, and this is like my 0. The cube root of 0. If I put negative 4 in, that gives me 0. If I put negative 3 in, that will give me 1. And if I put negative 5 in, that will give me positive 1. So I'm going to go negative 4, and then I'm going to use negative 3 and negative 5. And I know this one's negative 1. All right, so now I need this argument to be both 8 and negative 8. So I'm going to say real fast, x plus 4 equals 8. So I'll use 4, x plus 4 equals negative 8, and I'll use negative 12. Okay, so here we go. Negative 12, 4. Go very slowly, and notice that there's this pesky negative outside. So if I put in negative 12, I'm going to erase this, just so you know. But I feel like some people might need to see this. Negative 12 plus 4 is negative 8. The cube root of negative 8 is negative 2. This guy comes down. The cube root of negative 8 is negative 2 minus 1. So now I've got 2 minus 1 is 1. And if I switch this number to negative 5, Negative 5 plus 4 is negative 1. The cube root of negative 1 is negative 1. Negative 1 is 1. You gotta be really careful with this arithmetic. There is zero shame in writing this out. And now, because I'm pretty smart, you know, I'm the math teacher, I know what these numbers are. Okay, but please make sure you go through this arithmetic. If you use symmetry to help you out, more power to you, but make sure that you are, oh man, I don't have enough room. 11, 12, we'll go here. And then 4. Okay. And there, oop, I missed. And there's my graph. The increasing interval there is none, and the decreasing interval is all real numbers. So now go ahead and complete SLT 7A with your group.